All right, so the next topic that we're going to be covering is measurements of angles. An angle is said to be in standard position if its vertex is at the origin, its initial side is on the positive x-axis, a counterclock rotation represents a positive angle, and a clockwise rotation represents a negative angle. Okay, so that seems kind of like a lot. So pretty much we're just putting angles on top of a coordinate plane. So you're always going to start here on the positive x-axis. This is called your initial side. Okay, so that's where you start. And then you measure out your angles. So for example, if we went straight up and down, if you guys can notice, this is 90 degrees. And so that's kind of how we measure the angles, okay? But wherever you stop, because of course it's not just 90, we have, I don't know, 200, 170, whatever it is. But wherever it ends, in this case right here, this is called your terminal side. Okay, because that's where it terminates, that's where it ends. And that's going to be in standard position. Now, if we go counterclockwise, this denotes a positive angle. Okay, if you go clockwise, which is in this direction, that is a negative angle. Okay, so here we have a degree measure. The most common angular unit of a measure is degrees, so which is equivalent to 1 out of 360 or a full rotation about the vertex. I'm sorry. So it says sketch the angle in standard position. So here's our first one. We have 120 degrees. This is still going to be your initial side. Okay, so we're going to start here. And then let me go ahead and label my axes. That way you guys know. So this is 90 degrees. Okay, now this is 90 plus another 90 degree angle would be 180 degrees. Okay, plus another 90 degree angle. So 180 plus 90 is 270 degrees. Okay. Plus another 90 degree angle is going to be 360. Okay. So usually start here at 0, and then you have 0, 90, 180, 270, 360. Okay. Just a little note, we don't have to label this part, but half of 90 we know is 45, right? So somewhere around here is 45. So when you're putting in your angles, especially on delta math, when you put in your angles, that'll give you a good idea. Okay, is it going to be closer to the 90 or is it going to be closer to the 45? Okay, so this one too, this would be right in the middle is 135. This one right here is going to be 180 plus 45 is 225, right in the middle. And then over here would be 270 plus 45 is 350. Okay, so that's just to keep in mind, especially on delta math, because you're going to need to be a little bit more aware of the numbers when you put them in. But for here, it doesn't have to be 100% exact. Okay, so 120 degrees. Now 120 degrees is going to be between 135 and 90. Okay, so that is going to be about right here. Okay, then we need to put the little arrow to show that it is talking about the angle going in the positive direction. And that's it. That's how you sketch your angle. Okay, so looking at the next one, this is negative 45. So if we're going negative 45, then we're going to go in the opposite direction. Okay, this is going to be 0 degrees. This would be negative 90. This would be negative 180. This would be negative 270. And this would be negative 360. Okay, so negative 45, well, 45 is right in the middle of 90 and 360. So I would put my little arrow here. This is my initial side, this is my terminal side, and then we put the direction that it's going in. So remember, when it's clockwise, that shows your negative angle. As a matter of fact, I forgot to label it. Theta equals negative 45 degrees. So this little circle, the little O with the little cursive, that is the Greek symbol for theta. This one's 120. So let's go ahead and go on to the next one. We have negative 210. So here, let me label my axis. We have 90, but it's negative, so negative 90. We're going in the opposite direction. Negative 180, negative 270, and negative 360. So we start at 0 degrees. So then 210 is going to land in between 180 and 270, and it's actually going to be closer to 180 than it is on 270. Okay, so I'm going to put it like about right here. And so this is my initial side, and this is my terminal side. Okay, and we start here on our initial side, and we put a little arrow ending at the terminal side. Now remember, since we did go, since it is a negative angle, we do have to go in the negative direction. So it doesn't necessarily mean a negative number, but it does mean the direction. It shows you the direction you're supposed to go in. Okay, so here now we have 400. Okay, so I'm going to go ahead and start labeling my axis. So here I have 0, and the next one's going to be 90. The next one is 180. The next one is 270. Here we have 360, but one full circle around is still not enough. We still need a little bit more because it's 400. So 360 plus another 90 would give us 450. Okay, so then 400 lands between 360 and 450. So my initial side is going to be right here. My terminal side, 400 is going to be a little bit closer to the 360. And so when I make my angle, I start here and I show that I went all the way around one full circle and then I came back here. And that denotes a 400 degree angle. All right, and then let's see. So for some trigonometry applications, angles must be measured in radians. Your radian measure. So a central angle of a circle has a measure of 1 radian if it intercepts an arc with the same length as the radius. So here theta is equal to 1 radian. Okay, because what it's saying here is that this is my radius, and then they compare it to this part right here. All right, so the radian measure of theta is the number of radius units and the length of rs. So here, pretty much your arc length, they use a little s, so whatever the length it is from here to here, and then your radius r, which is from here to here, that denotes your theta. So that is in radians. So it's an alternate method to degrees, okay? You have degrees and you have radians. So here it says a full rotation corresponds to an arc length s equivalent to the circumference of the circle. 1 rotation equals 2 pi r. So one full circle, because circumference is 2 pi r, one full circle all the way around is 2 pi r. So 2 pi radians. So this leads to the following equivalent statements. If 360 degrees is equal to 2 pi, so one full circle around in degrees is equal to one full circle around in radians, then 180 degrees is just only 1 pi. Okay. So now converting between degrees to radians. So if you have degrees and you want to change it to radians, or you have radians and you want to change it to degrees, this is a formula that you are going to use. Okay. So going that way or going backwards from degrees to radians. So here I have 32 degrees. We're going to measure from radians, and we're going to change it, from degrees, and we're going to change it to radians. So we're actually using the second formula. They do want it in terms of pi. So the way that we do this is we're going to take 32 and we multiply it times pi over 180. Okay, so this is equal to, now in our calculators, we are going to put this in as, let me go ahead and do 32, divided by 180, let me move this, by 180, and then enter, functions. I'm going to go ahead and go to functions. I'm going to press fraction. So it gives me the fraction, or the simplified fraction here on Delta Math. It's 8 over 45. So the way that I write this is 8. I still have this pi at the top, so it'll be 8 pi over 45. All right, the next one, we have negative 225. In order for us to change it to radians, we want it in terms of pi, so the pi goes on top, the 180 goes on bottom. And then I'm going to go ahead and simplify the 225 over 180. So I'm going to go ahead and do 225 divided by, 220. Oops, 225 divided by 180. That gives me 1.25. I'm going to go ahead and change that. So 1.25 converts into the fraction 5 over 4. So here I'm going to put, remember it's negative, so negative 5 pi is on top over 4. Okay, and then that would be our answer. Okay, so the next one we have 50 degrees. We want to change it to radians, so we multiply it times pi over 180. And so to give our answer, we do need to leave it as a simplified fraction. So what I'm going to do here, I am going to put 50 divided by 180. I hit enter, and then I go to functions, and I wanted to change it to a fraction. So it changes to 5 over 18. So this is equal to 5 pi goes on top over 18. And this one's positive, this one's not negative. So that is 50 degrees in radian measure. The next one, write each radian measure in degrees. So here we have 3 pi over 4. So to change it to degrees, we're going to have to multiply by pi over 180. So we are using the first formula. Okay, so let me go here. Let me zoom in. And so we're trying to cancel out the pi. We're trying to get it out of terms of pi. So here, I'm going to have to multiply it times 180 over pi. And so when this happens, since you have a pi on top and a pi on bottom, they cancel each other out. And what we put on the calculator, it's going to be 3 times 180. So 3 times 180. Enter, and then we're going to divide that by 4. Oh. The answer divided by 4. That gives us 135 degrees. Okay, so same thing for this one. I'm going to go ahead and change this to radians. So we're going to have to multiply it times 180 over pi. The pi's cancel each other out. This is equal to. Now, unlike the other one where I had a 3 here in the front to multiply, I don't have that on this problem. Okay, so then we just have negative 180 over 3. Which we can simplify. That actually gives us negative 60 degrees. Okay, and the last one, here we have 3.8. So this one isn't in terms of pi, so we're just going to go from 3.8, we're going to multiply it times 180 over pi. Okay, so here I'm going to do 3.8 times 180 over pi. That gives me 217.7. So 217.7 degrees. And that's it for those ones. All right. So this one, it says sketch each angle in standard position. There's several ways you can do this, okay? The first one, we can go ahead and change this into degrees since you guys are a lot better at using degrees. Or we can use fractions, which I know some of us are not a fan of fractions. Okay, so I'm going to show you both ways. Okay, from here to here is pi. This is pi. Okay, so it's half a pi. And one full rotation is 2 pi. Okay, this is half a pi, and then this would be 3 pi over 2. Okay, so that is our thing in fractions. Okay, so since from here to here is 1 pi, okay, and they want us pi over 8, I can cut this into 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. And it only wants 1 out of the 8 pieces, 1 out of these 8 pieces. So this line right here is only the first. So then I would go ahead and erase the rest of them. Okay, and then that would be my angle. Oh, whoops, I didn't mean to erase that. Here, here, and that would be my angle. Okay, we can also change it, like I said, to degrees. So I go ahead and multiply this times 180 over pi. The pi's cancel out, and then we have 180 divided by 8. Let me go ahead and see what that gives me. 180 divided by 8, enter. It gives me 22.5. So 22.5 degrees. So then if you would rather do it in degrees and not have to deal with the fractions, you can go ahead and do that as well. And then 22.5 would lie in the first quadrant between 0 and 90. All right, the next one, number 16, 4 pi over 3. Okay, I'm going to do the same thing like we did on the last problem. So first we'll do it in radian measures. That's pi over 2. This is pi. This is 3 pi over 2. And then this is 2 pi. Okay, and then of course you start with 0. So we have 4 pi over 3. So we're going to have to cut this into thirds. So from here to here is 1 pi. And we cut it into thirds. So this would be cutting it into thirds. Okay. But then we see how many pieces of the pie do we need, and we actually need 4 pieces. So this is 1, this is 2, this is 3, and so then a 4th piece in that's the exact same size would be right here. So that would be considered 4 pi over 3. I'm just going to erase all the extra parts that we don't need. We don't need those numbers. We don't need that part. We do need this part. Okay. And then that would be my angle theta. So theta equals 4 pi over 3. Once again, if you're not good at fractions, okay, say you don't like the fractions, go ahead and change it to radians. So, to degrees. So we go ahead and multiply times 180 over pi. The pi's cancel, and then in my calculator, I'm going to do 4 times 180. Enter, and then I'm going to divide that by 3. Oh, whoops. My answer divided by 3. Enter. That gives me 240. So if you're better at doing it in degrees, then you can go ahead and do that. This is going to be considered 180. This is 270, so 240 lands right in between 180 and 270. All right, this next one, this one is negative. So from here to here is going to be negative pi. This is negative half of pi. This is negative 3 pi over 2. And then this is negative 2 pi. And then, of course, we start here at 0. Okay, so then we're going to go ahead and take from here to here is 1 pi, okay? And so they want us to cut it into fourths. So the 1, 2, that's 4 equal pieces. And because there's no number here in the front, it is an imaginary 1. So that means that this angle here is only 1 out of the 4 pieces. So then this is our angle theta. Or I should have done it in a different color. So theta equals negative pi over 4. All right. And this last one, we have negative 5 pi over 6. So we're going to go backwards. This is 0. This is negative pi over 2. This is pi. This is 3 pi over 2. And then here is 2 pi. Okay, so we are going in the negative direction, which is clockwise, and we have 5 pi over 6. So here we go. There's my little pi. Let me do the pi in blue. Okay, so here's my little pi. And I need to cut this in 6 pieces. So this is 1, 2, 3 pieces, and then I'll cut those in half. And there you go. There's my 6 pieces. But we only need 5 out of the 6 pieces. So this is 1, 2, 3, 4, and 5. So the 5th piece would be right here. I'm going to go ahead and erase all the parts that I don't need. I don't need this. And so here's my angle from here to here. And that's theta equals negative 5 pi over 6. Okay. Let's see. So quadrantal angles, if the terminal side of an angle, it lies along the axis, this angle is called the quadrantal angles. The following are examples of quadrantal angles. Give the measures in both degrees and in radians. So if they tell you 90 degrees, well, this is considered 90 degrees from here to here. Now, it is also considered, if we went in the opposite direction, it's also considered negative 270, okay? Same angle, same location. That's why it's important that you put the, well, you know what? It might be the positive angles is a definition. Yeah. Let's just erase that. Okay, they also want it in radians, so then the radian measure would just be half a pi, pi over 2. And then, for example, this one, oh, see, this one already goes in the negative direction. This one is going in this way. That is 270, negative 270. And in terms of pi, that would be negative 3 pi over 2. All right, guys, that's it for me. If you guys have any questions, go ahead and contact me. Leave a comment. Thank you, guys. Bye.